I'm Matthew Napoli, the Deputy Program Manager for the 3D printing in zero-G experiment, which was the first 3D printer on the International Space Station, launched in 2014. This 3D printer is a technology demonstration and a science experiment on board the International Space Station. And the experiment was to test 3D printing in microgravity. And to do this, we printed a variety of test coupons, about 14 unique items, and a few of them were material testing coupons, your standard tensile coupons, compression, flexure strength coupons, which give you the properties, the material strength properties of an item. And so we printed multiple copies of this on the space station, as well as on Earth with the exact same printer and same material, so we can do a comparison in the future. In a few weeks' time, the parts printed on the space station will be delivered back to us, and with our partners at NASA, we will be analyzing all the printed parts for comparison and learning more about the materials so that we can in the future design appropriately for the material properties that we will now know. The 3D printing in zero-G experiment is a unique one-of-a-kind printer. The major challenges is operating in microgravity. Most 3D printers, terrestrial 3D printers we call them, use gravity to weigh down certain subsystems and keep everything in place. This one has to be able to operate in a floating environment where some of the parts may float, the print tray, the print head, the feedstock, everything can float and cause trouble. So the first challenge we did was to eliminate all the gravity effects on a printer and allow it to operate without that. And we did that through zero-G parabolic flights, which it's an airplane that gives you about 20 seconds of zero-G, and then 20 seconds of 2G, and then 20 seconds of 0G. And doing that, we can test in really short bursts the microgravity effects on a printer. So last year, when we had our first ISS mission, we had no issues with microgravity, and everything performed as designed. We had to select components that are all preloaded, have no play or backlash or hysteresis, and just really high quality components, which makes us one of the most expensive 3D printers available. But so that was the first step, and then the second step is the print process, where we needed to have surface tension dominate, because you have a molten flow of polymer, and you need it to stick together and touch together. And by bringing the print head close enough to the part and controlling that distance, the material will flow directly onto the part and not float off into space. Currently, most items, including this printer, are designed to survive launch. It's rugged, metal, really strong, really durable, because it has to survive the launch of a rocket to the space station. This wasn't designed for space, but now you can print parts designed for space, where they're extremely optimized, extremely lightweight, using the least amount of material possible. And so you can, we can design spacecraft, space components kind of in a brand new way, where we're not designing them for launch, we're designing for their actual use case, which is really exciting and opening kind of a whole new area of thinking and design for spacecraft. This is just the first step. The goal is to expand this technology, increase the amount of materials we can print with, go on to metals, and eventually what we call in situ resource utilization, which is using the materials in space. So lunar regolith, asteroids, Martian dirt, items already on the space station, we can reuse them and repurpose them and manufacture with them again. So the ultimate goal is to use the stuff available in space to manufacture new parts that we need. We're also working on a contract with NASA to develop a recycling system that'll be complementary to the 3D printer, where after you're done with the part or the item that you're using, you can put it in the recycler, it'll turn it back into feedstock, and we can print again. So it helps cut out the the material that needs to be launched to the space station will have a material that's just constantly being recycled, reused, reprinted. And so those are kind of the next near-term things. Designing something for space and not for launch is a brand new way of thinking. We're getting engineers all over NASA and universities and large corporations really interested in doing some demo prints with us and our printer on learning how to design for space and optimizing. It's a brand new way of thinking because this capability wasn't available before this printer. And so it's opening a lot of new areas of study for the future.